Hello everyone, this is Johanna Princess Saavedra. Today we will be solving two problems about liquid-liquid extraction. The first problem is the distribution coefficient of a solute A between solvent B and S is given by y equals 2.5x, where mass of B in extract and x mass of A over mass of B in raffinate. S and B are mutually immiscible. A solution containing A and in B is to be extracted in a single stage contact with a recovery of 80% required for 100 per 100 kilograms of solution is nearly blank kilogram. So for solving this, first let's look at the problem. We are given the distribution coefficient, which is y equals 2.5x, and where y is mass of A over mass of S and x is mass of A over mass of B. We have our mass, which is the 100 kilogram of solution, which is 25% A equals to 75% B. We want an 80% recovery of A. We need to find how much solvent S is required. So, step 1, let's find the initial masses. Since the solution is 100 kilograms, is 75% of 100 kilogram is equals to 75 kilogram. And mass of A is equal to 25% of 100 kilograms. We have 25 kilograms. The next step is to calculate how much A is recovered and how much remains. So we want 80% recovery. So mass of A recovered. So we have to use the 80%, which is 0.8. We have to multiply this by the mass of A, which is 25 kilograms. This is equal to 20 kilograms. Next is therefore mass of A left in B is 25, so minus 20 kilograms. I'm just gonna put here mass recovered and mass A left. So we have 25 kilograms minus 20 kilograms. So this, we only have 5 kilograms left. So next is to find the value of x. So x is mass of A divided by mass of B. So our equation is x is equals to 5 over 75 is equal to 1 over 15. So this is approximately 0.0666. So next step is to find the value of y. Using the given equation, which is the y is equal to 2.5x, we have to use the solution, which is y equals to 2.5x. We have to multiply it by the x, which is the 1 over 5, getting the answer 2.5 multiplied by 1 is equals to 1 over 6. This is approximately 0.16667. So the next step that we have to do is solve for S. Remember that Y is also equal to mass of A in S divided by mass of S. So we know Y is already 1 over 6 and the mass of A is 20 kilograms. So 1 over 6 is equal to 20 over S. So by cross multiplying, we get 20 times 6. So 20 times 6 is 120 kilograms. So the final answer is 120 kilogram of solvent is required. So now let's move on to our problem 2. The distribution coefficient of A, soluble A, between solvents B and S is given by Y equals to 3x, where Y mass of A over mass of S in extract and x equal mass of A over mass of B in raffinate. S and B are mutually immiscible. 100 kilograms of 30% solution of A and B is to be successfully treated in 2 batch contacts with 60 kilograms solvent each time. The overall percent recovery of A is very nearly blank percent. So given here, the distribution coefficient is y equals to 3x. So we have our mass, which is 100 kilograms again of solution, then which has our A is 30% and our B is 70%. So we will do the 2 successive extractions using 60 kilograms of S each time. We need to find the overall percent recovery. That is what we are finding. So our step 1 is the initial masses. So the first one is mass of B is equal to, using 70% of 100 kilogram, is equal to 70 kilograms. A is initially 30% of 100 kilograms, so this is 30 kilograms. The first stage is, let's call the amount of A remaining for the first stage A1. So in X1, A over mass of B. So our A1 is equal to, so our Y1, which is 3, we have to multiply it by X1. So this is 3 multiplied by our X1, which is A1 over 70 kilograms. So that is our Y1. Then now we have to do a mass balance, which is total A is equal to A remaining plus A extracted. So our total A is 30 kilograms. Our A1 plus our Y1 times our S. So our A1 is 1 plus our Y1, which is 3 multiplied by A1, over 70 kilograms times 60. We have to shift solve this. By shift solving this, we get 8.4 kilograms. So after the first stage, 8.4 kilogram of A remains. That means we extracted 30 minus 8.4 kilograms. We extracted 21.6 kilograms. So now the second stage, now we take the raffinate from stage 1, which has 8.4 kilograms of A, and extract it again with another 60 kilogram of S. So let A2 be the amount remaining after the second stage. Using the same formula, which is 8.4 equals times 25 over 7. So our A2 on the right places. I'm just multiplying this, so we get 2.352 kilograms. So the second stage we extracted is, so using the 8.4 kilograms, we just have to subtract 2.352 kilograms equals to 6.48 kilograms. So our overall recovery, so total of mass extracted, mass of A extracted is equal to 21.6, which is our first kilogram, plus our second, which is 6.048 kilograms. We have 27.648 kilograms. So for solving the percent recovery, we have the formula total extracted over initial A. Multiply this by 100%. Then substituting, our total extracted is 27.648 kilograms and our initial A is 30 kilograms. Multiply this by 100% and we get total of 92.16%. So overall percent recovery is nearly 92%. So, and that's it. We have solved both problems, and thank you for watching.